Good morning. Please look at your workbook, page 1 at 7. I will discuss the question here. So look at question 1. A particle move at, so this one, they give you the formula. V in terms of t. V in terms of t. And then they say, find initial velocity. So how you're going to find initial velocity? Initial meaning that t equals to 0. So when t equals to 0, what is the v value? So you just substitute t equals to 0. So this 2 equals to 0. Then you get the v equals to 5. So this one is the initial velocity. So remember the keyword initial meaning that when t equals to 0, what is the value? So now part B, instantaneous velocity when t equals to 3. So what you need to do, you just substitute t equals to 3, put inside the formula of v. So you see, substitute, key in calculator, getting -4. Question C, find the range of t value when the particle move to left. So the keyword particle move to left, remember, is actually refer to v less than 0. V less than 0. Okay, you cannot say S less than 0. If S less than 0, meaning that the particle is at left side. If S less than 0. S greater than 0, particle at right side. So for these cases, they say particle move to left. So the most appropriate one will be V less than 0. So you just apply the formula and let it less than 0, and then this one is a quadratic equation. When you have quadratic equation with the inequality like this, then what you do, you just do factorization. Then when you factorize, you have two value of t. So 1 and 5 like this. So 1, 5 less than 0. So we choose bottom. So your answer is 1 until 5. Then question D, value of t when the particle stop. So the keyword for particle stop meaning that v is 0. So v is 0, just let the equation that you have for the v equals 0, factorize it and solve it, and you get two answers. So look at question 2. This one similar, give you a velocity formula. And then question A, find instantaneous velocity when t equals to 4. So what you need to do, just substitute t equals to 4, put inside the formula, and then you get the answer. Question B, calculate the value of t in second when the particle stop. So when particle stop, remember the keyword is v equals 0. So just apply formula like just now, equals 0, because this one is a quadratic equation. So you need to do factorization like this, and then get 2t value here. Question C, determine the range of t in second when the particle move to right. So remember, particle move to right, we use v greater than 0. So substitute quadratic equation. When you get these two quadratic equations, you need to do factorization. After do factorization, you have two value of t. One is 1, one is 7. And then draw a smiley face because it's A is positive, greater than 0, so we choose above. So by right, when you do, you should write like this. If the usual case, your answer is like this. But because of this one, t is stand for time. So you need to do some adjustment. Then this t, this part, because if you write t less than 0, meaning that t can be negative value. But t is a time, so cannot negative. So what you need to do, you need to add this in. So meaning that t, the minimum value for t is 0. Okay, and then this part, you just copy down, less than 1, and then t greater than 7. So this one, don't write. So the answer at here is wrong because this part wrong. So this is the final answer. So now look at page 1 at. So this one is about acceleration. So acceleration, what is acceleration? This one already teach you, so I straight away discuss the exercises. Question 1, page 1 at. A particle move along a straight line. So now they give you acceleration. Calculate initial acceleration. So same, initial meaning that t equals to 0. So just substitute t equals to 0 inside the then you get the answer -5. Question B, calculate the instantaneous acceleration at t equals to 3. So when t equals to 3, you just substitute t equals to 3, put inside the acceleration formula, then calculate, get the answer. Question C, range of time in second when the velocity decelerating. Remember, velocity decelerating meaning that a is less than 0. So this is the keyword. So just apply the formula less than 0. And this time, this one is linear equation. So no need to draw graph. Straight away solve the inequality and get t like this. When you have t less than one number, remember always need to add in this part, become 0. The smallest t value is 0 because refer to time, and then this part just copy. So this is the answer. Question 2. This question also the same, give you the formula A. Then question A, find instantaneous acceleration when t equals to 5. So very simple, just substitute t equals to 5, put inside the formula of A, simplify, get the answer. Question B, find the time in second when the velocity is maximum. So remember, velocity maximum meaning that dv dt equals to 0. Previously, you have y equals to, let's say, ax squared plus bx, example. Then the question say, find the x value when y is maximum. So what we do? We'll do dy dx equals 0, right? So these cases also the same. So they talk about velocity maximum, meaning that dv dt equals to 0. Okay, this dv dt refer to a. So meaning that a equals to 0 for these cases. So you can just highlight the keyword next time when you see velocity maximum actually refer to dv dt equals 0 or a equals to 0. So straight away apply the formula a equals to 0, solve it, get the answer. Question C, find the range of time when the velocity is increasing. Remember, velocity increasing, a should be greater than 0. A should be greater than 0. So this one is careless mistake, typing mistake. So 2 at minus 2t is greater than 0, meaning that minus 2t is greater than this at bring to right hand side, so negative at. So t, this one divide negative 2, so become 4. So this one, remember, when you divide a negative number, your range, this sign will change. So become t less than 4. So when you get the range like this in this topic only, the other topic just copy. In this topic only, if you get t is less than one number, you need to add this part in, 0. Minimum t value is 0, remember. So this is the final answer. So now look at page 190. I discussed this question. This question, they give you S in terms of T. Give you formula. Find the time when the particle come to rest. Okay, what do you mean by come to rest? Remember, when you see rest, meaning that V equals 0. Just memorize the keyword. V equals to 0, so just substitute V. How to get V from S? So remember, how to get V from S? We do differentiation, ds dt. Then you will get the V, yeah? So differentiate the S. So S equals to t squared minus 3t plus 2. So V equals to ds dt. So just differentiate like usual. 2 bring down. 2 times 1 is 2. T copy down, power minus 1 become power 1. Minus 3t, you differentiate, you're getting minus 3. Differentiate 2, you're getting nothing. So simplify, this is the V formula that you have, velocity. So V equals 0, substitute, get the t value that you want. Question B, velocity when t equals to 3. So very simple, just substitute t equals to 3, put inside the formula, then get the answer. Question C, find the range of value of t when the particle move to right. Particle move to right. So remember the formula. Oh, wait. Look at question C first. Question C haven't discussed. The range of value of t when the particle have negative velocity. So the keyword is negative velocity, meaning that velocity is less than 0. So just substitute and then get the answer. 2t minus 3 less than 0. So 2t less than 3. T is less than 3 over 2. So remember just now I said when the cases in this topic, when you're involving time less than something, need to add in this part. So this is your final answer. And then question D, range of value of t when the particle move to right. Particle move to right, V greater than 0. Remember, this is the keyword, so just substitute. And this one is a linear equation, so you just solve like usual, no need to draw graph. Unless it's a quadratic, then you need to do factorize and draw the graph. Question E, the initial velocity. Initial, again, t equals 0. So just substitute and get the answer. This topic, actually, you can score quite easy. Page 191, because all follow similar pattern and then follow the keyword. So S equals to, this time they give you S, displacement. So question A, find the value of t when the particle is 4 meter to the left of all. Remember, 4 meter to the left, S is a negative value. So S is negative 4. So just substitute S is -4, the formula, and then notice that this one is a quadratic equation, so just rearrange, become a the quadratic equation in terms of ax squared plus bx plus c equals to 0. Rearrange, become this term. Then factorize it. I think this one should be 0. Typing mistake. Factorize it and then get 2t value. So remember, t is time, so need to choose the positive answer. Question B, the range of t in second when the particle moves to right. So remember, particle move to right, meaning that v is greater than 0. How to get v from s? So just do ds dt. Differentiate the displacement, then you can get the velocity. You'll get t 3 minus 2t. So just substitute greater than 0 and get this answer. So remember, need to add in this part. Question C, maximum displacement of the particle. So maximum displacement meaning that ds dt equals 0. Highlight the keyword when you see maximum displacement. So ds dt equals to 0 or velocity equals 0, because velocity equals to ds dt. So just apply the formula like just now, get t equals to 3 over 2. So your displacement will be maximum when t equals to 3 over 2. So what you need to do? Need to substitute, because the question asking you find the maximum displacement. So substitute t equals to 3 over 2 inside your S formula, then get the answer. Question D, total distance traveled by the particle in the first 4 seconds. When you find total distance in these cases, we actually have two methods. So method 1 is using number line. Method 2 using graph. So it's up to you which method you like. So if you want to do for method number 1, you need to find when t equals 0, t equals 1, t equals 2, whatever, equals to s is equals to what, so that you know the position of the movement. And then remember, find maximum and minimum. This part is maximum s. This part is minimum s. So that we know until where it turn back. Then we know where is it position. So when t equals to 0, s equals to 0. So we just draw like this, t equals 0. And then because just now we have find here s maximum, meaning that until here it will turn back to the left hand side. So at this part, t equals to 3 over 2, the s is maximum until 2 or 1 over 4 like this. After that, you need to know it turn back until where. The question got said or not in the first 4 seconds. So you try to find t equals to 4. What is the s? So after t equals to 4, you get the s is -4 meter. So meaning that at this part, -4. So from here, you can find total distance travel. We know it moves like this. So you can use 2, 1 over 4 plus 2, 1 over 4 plus 4. Then you get the answer at 1 over 2. And then if you don't want to use method number 1, you can use method number 2 by drawing the graph. So how we draw this graph? So this graph is displacement graph. So if it is displacement graph, what you do? How you draw the graph? Displacement equation is a quadratic equation. Look back here. It's a quadratic equation. See? So just draw quadratic graph. So you see A is negative, so you have the graph look like this. Just draw this quadratic graph, and then how you know the displacement? Here to here, you already travel 2, 1 over 4. And then here to here also, 2, 1 over 4. Here to here is 4. So just plus it, get the answer. So two methods, up to you which method you like. Now refer page 192. So this one. C again give you the formula of displacement. Find initial velocity. Initial velocity meaning that t equals to 0, v is what? Then you need to have velocity formula. How to get velocity formula from displacement? So what you need to do, you just differentiate the s, displacement that you have, ds dt. So differentiate, you get at t minus 24. So this one actually is your v. So just substitute t equals 0, get the answer -24. Question B, the time when the particle is stationary. So remember, when particle stationary or not move, meaning that v is 0. So substitute velocity formula in and get the t value. Question C, range of value of t when velocity is negative. So velocity negative, v less than 0. Just apply the formula and get the answer. Remember, when you get t less than one number, must add in this part. Minimum value is 0. Question D, sketch the velocity time graph for the movement 0 until 4. So velocity graph is a linear equation. So you simply find two coordinate and draw it. 0 to 4. You can go to find v equals 0. At t equals 0, what is the v value? T equals 4, what is the v value? Connect it. Then this is the graph that you want. Okay, I stop a while. I stop a while.